Yeah, hi, I'm a nursing student, so I find that there's a bit difficult to learn about ABG gas and arterial blood gas and about the pH, PaCO2 and the bicarbonate level. So I find this easy to remember formula, so it's useful. Yeah, you can try it. Okay, so what I do is that I put the pH here from 7.35 to 7.45. That's the normal range of pH. And I put my CO2 level here, and to make it easier to remember, you can invert it. So I put 35 here, 45 here. So you need only to remember those two numbers. And the level of bicarbonate I put over here, and it's easy to remember too, because you just multiply 7 over 3. 7 multiply 3 is 21, 28. So what you do is that when they give you a number, like for example, let me get an example. Okay, I have example pH 7.33, PaCO2 55, HCO3 29. What I do is that 7.33 is smaller than 7.35, so I put a dot here, and then PaCO2 is 55, it's larger than 45, so I put over this side because it goes from 35 to 45 to the left. And for bicarbonate, it's 29, so it's bigger than 28, so it's over here. So the conclusion is that since you're less than 7.35, you're acidosis, because less than this is acidosis, and over this side is alkalosis. Okay, so and you look at the dots. If the dots they're on the same side, that's the cause. So if it's CO2, that's the respiration, and if it's bicarbonate, it's metabolic. So this one, you get the result that's respiration acidosis, because it's caused by CO2 and it's acidosis. And because it's less than 7.35, it's uncompensated. So you get uncompensated respiratory acidosis. And even if you don't know the number here, you can know the bicarbonate level will go up to compensate it. Here's another example. Let's say pH 7.2, PaCO2 30, bicarbonate 20. So we do another one. I just put on the same here. Okay, 7.2, so still acidosis. And by CO2 30, so it's over this side this time. Okay, let's use a cross here. Okay, bicarbonate is 20 over this side. So because the two cross are on the one side, you know that it's the metabolic alkalosis. So you know it's metabolic alkalosis. And you know it's uncompensated because it's less than 7.35. Still uncompensated. So if for example you have something over here, like the pH is 7.5 for example, and then CO2 is like 20, and bicarbonate is whatever, it's like 15, and you know they're on the same side, so this alkalosis you know right away, and you know the cause because it's on the resp side, so that will be the uncompensated respiratory alkalosis. So if the pH, for example, move to here like 7.4, it's closer to alkalosis, you know it's compensated metabolic alkalosis. Okay, so I hope that helps. Thanks.